Is an
ultraviolet,
and it's showing, or is it in radio?
Oh, there it is.
I think it's in ultraviolet.
We're going.
Come on in.
I see the final show up.
And so Venus is the closest planet to the Earth. It's covered with clouds, and the clouds are so thick you can't see through them. So this picture is a picture of the surface taken with something that penetrates the clouds, and it might be UV. I think it is UV. And so it shows that the lighter colored parts are higher up, and the blue colored parts are lower. That's what the surface of Venus looks like. Now Venus has thick clouds, and to us, when you look at Venus from the Earth, it looks like a really bright star. It looks like the brightest star in the sky. It's not a star, it's Venus. And the reason why it's so bright is because it's got these white clouds, and it reflects almost all the sunlight that bounces off of it. And so you see it as really bright. It's so bright, it's been mistaken for some things. Like I read one story about a conductor on of a train. Venus was rising on the horizon, and it just happened to be rising right in front of the tracks, and he thought it was an oncoming train on his track. And he slammed on the brakes on the train. Scared everybody to death. And it was just Venus. Isn't that a cool story?
Yeah.
Wait, it rose on the horizon right where he was.
Yeah, it rose on the horizon right on the track.
Chris's head's like right in the way.
It looked just like a train lamp.
Precision. Better safe than sorry.
Venus is closer to the sun than us. So you always see it near the sun. It and Mercury are always near the sun. So, let me show you what I mean by that. Let me get some models out. Okay, let's say this is the sun.
Gotcha.
And this is the Earth over here. Now, of course, this isn't to scale. Are you with me, Amy? You got to watch this. So, Mercury is really near the sun.
Venus?
Well, let's start with Mercury. Mercury is really close to the sun, so whenever we see Mercury, it's always close to the sun, so it's really hard to see. The only time you'll see it is when the sun sets below the horizon. If Mercury is right here, and the sun sets below the horizon, you can see Mercury and not the sun. Or when the sun is rising above the horizon, if Mercury comes up first, you can see it for an instant and not the sun. But as soon as the sun rises above the horizon, you're not able to see Mercury. Mercury's hard to see. Now Venus is further from the sun than Mercury is. So Venus going around the sun like this, whenever the sun sets below the horizon, you're very likely to still see Venus. So Venus is always, if you want to find Venus, it's always in the direction of the setting sun or the rising sun. So if you see a real bright star in the sky, and it's in the same direction as the setting sun, it's probably not a real bright star, it's probably Venus. Or before sunrise, if you see a really bright star and you notice the sun's about to come up in that same general area, that's probably Venus. Y'all see what I'm saying? Know what I mean? Do y'all feel? So Venus is really bright. Why is it so bright? Why does it reflect so much sunlight?
Because of thick clouds.
It's got real white clouds. Now what are the clouds made of? They're mostly sulfuric acid.
That's
and sulfur
Amy.
compounds. Is that you checking out, Amy?
Evacuate.
Amy, checkout call? Ah, prediction. Okay, fine.
That would have been funny if she said no.
Alright, thank you, Mr. Willis.
Thank you. Have a good, safe trip. So what are the clouds made of? sulfuric acid and other sulfur compounds and carbon dioxide. There's a huge amount of carbon dioxide in Venus's atmosphere. Where did it come from, you might ask? Well, we think that Venus was like Earth about 4 billion years ago. We think it had land and oceans and everything.
What?
It's about the same size as Earth. Venus and Earth are almost exactly the same size. Venus is a tiny bit smaller than Earth. So if I was holding Mars is about this size, and Mercury is a little bit smaller than Mars, and here's Earth, and Venus would be just about as big as the Earth. So it could retain an atmosphere, it could retain heat and water, and about 4 billion years ago, the sun was not as hot as it is now, and we think that weather would have been perfect on Venus, just like the Earth. But what happened was the sun got a little hotter. Venus is much closer to the sun than the Earth is, and the atmosphere held in a lot of the heat and boiled away Venus's oceans. Now, something you may not know about the oceans, Amir, are you with me? Something you might not know about our oceans, they hold a lot of carbon dioxide. A lot of carbon dioxide. And if the oceans evaporate, all that carbon dioxide goes into the atmosphere. The water molecules stay in the atmosphere too, but if you're this close to the sun, the water molecules will all be broken apart by the sun's energy, and the hydrogen will escape into space. And the oxygen will sink down and sink into the rocks, and you're left with nothing's left of the water. So all of the water on Venus is gone. But the carbon dioxide stays. So 98% of Venus, 99% maybe, of Venus's atmosphere is thick carbon dioxide. And the air is so thick there with carbon dioxide that it's about 93 times as thick as our atmosphere. If you were on Venus, the atmosphere would weigh on you heavily, as if you were down deep underwater. And it would push on you, and the pressure would be so great it would crush you. Venus's atmosphere. And if it didn't crush you, if you had a suit that had pressure inside to equalize the pressure so it wouldn't crush you, you would still move through the atmosphere. It would be real thick, and it would be hard to move through it. I mean, wave your hand. Right now, wave your hand through the air. You feel the air moving past it? It'd be 90 times as heavy to move your hand through the air. It'd be like moving your arm through water when you're underwater. That's how the air is on Venus. But there's no oxygen, it's carbon dioxide. And it's real hot. If you want to try to see how hot it is on Venus, turn your oven all the way up to broil.
And stick your head in it.
And then stick your head in it. And it's about 300 degrees hotter than that. It's about 850 Fahrenheit on Venus, everywhere. Because that carbon dioxide atmosphere traps heat. It causes what's called the greenhouse effect. Have you ever heard of the greenhouse effect? We have it on Earth. It keeps the Earth at a nice temperature. But on Venus, there's a massive runaway greenhouse effect. There's way more carbon dioxide in the atmosphere. Carbon dioxide is really good at trapping heat. And so that planet is hot. It's hotter than Mercury. Yeah.
Why wouldn't it just keep getting hotter and hotter and hotter and hotter?
Well, it doesn't have any more carbon dioxide. Well, it does leak out some heat.
Okay.
So it has found its equilibrium with space, and it keeps in as much heat as the carbon dioxide can hold, and the rest of it escapes.
Okay.
So it's at an equilibrium point. Now, if somehow you could pump more carbon dioxide in there, it would get even hotter than it is now. But it's pretty much got it. All the carbon dioxide that was in the oceans from billions of years ago is now in the atmosphere. Did you know that plants use carbon dioxide to grow?
Yeah.
So if you could get some plants there, they could somehow tolerate that heat, they could suck it in and grow and make oxygen, you might be able to get the carbon dioxide out of the atmosphere. But the plants can't tolerate that much heat, so I don't know how you'd do it. There are cooler parts of Venus. You know where they are?
The poles.
The poles are a little cooler, but not much, because that heat is circulated around the planet by the gases. Way up in the atmosphere. The higher you go up in the atmosphere, the cooler it gets. So it's hypothesis. Well, eventually it'll get normal temperatures like we have here on Earth if you go up high enough. And then if you keep going higher, it'll even get colder. And the thing is, if you go up higher in Venus's atmosphere, the pressure isn't as bad. So you get to normal pressures eventually when you go up high. Scientists think that there's a point in the atmosphere of Venus where the temperature and pressure is just right, that there might be organisms living there, floating around in the atmosphere. Kind of like how organisms float around in the ocean. The atmosphere is real thick, so it's almost like water. It could sustain you, make you buoyant. And so there's a hypothesis that there might be life in the upper clouds of Venus, floating around, like little bacteria floating around, living up there. Isn't that a neat hypothesis? We don't know if it's true or not. We'll have to investigate Venus to see, but it could possibly be.
Why haven't we sent a probe? Have we sent a probe?
We have. They've sent a probe through Venus, but it wasn't equipped to detect little bacteria and stuff. It just measured temperature and pressure and that sort of thing. We've sent a few probes down there, and the Russians, we didn't do it, the Russians did it. They landed on Venus like 10 times. But they didn't look for anything up in the upper atmosphere. They landed and took pictures and stuff. I'll show you some of those pictures. Oh, by the way, Venus has a liquid metal outer core and a metal inner core. So it's just like us on the inside, very similar. It's got a thick, what's the part here called? Core mantle. It's got a thick mantle, and it's got a crust, and it's got liquid hot magma in the mantle that bubbles up and causes volcanic activity. It has live volcanoes that are active volcanoes on Venus, and they can spit out carbon dioxide too. Venus has a weird spin. The Earth spins one way. Most planets spin the same way they orbit. So if I was going to show you how Earth spins, if this is the sun, go out here. Earth, if you're looking from the North Pole down, Earth spins counterclockwise. Don't spin. Here we go. Earth spins counterclockwise like this, and it orbits counterclockwise. So it spins the same way it orbits. Does that make sense? Almost all planets do this, except Venus.
And Uranus, right?
And Uranus, yes. Venus and Uranus spin opposite to the way they orbit. They spin like this. They orbit this way, but they spin the other way.
Why is that?
Why is that? It's a good question. Scientists think Venus got impacted a long time ago. And they think, imagine if Earth spun like this, if it got impacted and it's flipped it upside down. Then it would spin in the opposite direction. So you're spinning like this. Now you're spinning in the opposite direction. You see what I'm saying? They think it got knocked upside down, which is what they're showing there. You can use what's called the right-hand rule. If your thumb's pointing up, the spin is going the same way your fingers curl. So if your thumb's pointing down, the spin's going in the opposite direction. It's called the right-hand rule. So my thumb's pointing up and the spin's going this way as it goes around. If my thumb gets knocked down, the spin will go the other way. It's called the right-hand rule. They use it on a lot of things that spin. It kind of helps you think which way things spin, the way your fingers curl. Yeah?
I got a question about the gas giants, just really quickly. Because I've always, I don't know, like, this might be a really stupid question. But if you were like to just like, if you could possibly just like walk through, like could you just basically walk through one of the planets? I mean, it would take like a really long time, but like, is there like a core or anything?
There is. There's a hard metal core that's liquid and then solid. Okay. Way down deep in the gas.
Wait, is it just gas?
It's gas all the way till then. But the gas gets more and more compact and more pressure, and eventually gets liquid when you get far enough in, and then eventually gets solid if you get.
Would it be like clear, or would you like?
No, it wouldn't be clear. It's metallic hydrogen, is what it is, which is kind of a metal color. It's opaque; light won't go through it. But way before you got to that, the gases would be such high pressure and temperature that you'd burn up before you could get there.
Yeah.
We actually sent a probe into Jupiter from that Galileo mission. It had a little probe on it. It launched into Jupiter, it had a parachute, and it just parachuted down, and it eventually got so hot it burned up the parachute and then melted the probe.
Did we know that was going to happen? Or
Yeah.
Like...
You can mathematically predict the temperatures going down, and pretty much matched our predictions.
But Venus is the planet you were talking about. It's just like, is it the slowest rotation?
It rotates really slow. And not only does it rotate backwards, it rotates really slow. It takes something like 247 days or something like that.
243.
243 days to go around once.
Yes.
So so we take 24 hours to go around once.
That's it says one turn every 243 Earth days, and then 244 days to orbit the sun.
So it's not only orbiting in the backwards direction, orbiting backwards, it's orbiting real slowly backwards. So it takes 243 Earth days to rotate once. And how many Earth days to go around the sun?
224.
It takes 224 Earth days to go around the sun once, and 243 Earth days to rotate on its axis once. So its year is faster than its day. And that's messed up. Venus is a weird place, man. And Venus doesn't have much of a magnetic field. Can you guess why? It's got a liquid metal core.
It's not rotating.
Spins too slow. Have much of a magnet. It's got a little bit of one, but not much of one. It's kind of like Mercury in that effect. Mercury's got a liquid metal core, but it's not spinning fast, so it doesn't have much magnetic field either. Mercury and Venus kind of have the same weak magnetic field. Video footage? Video footage of Venus's spinning. Oh, this is a good look at what Venus looks like, too.
Is it real?
Of course, this is sitting under the clouds. They don't show the clouds here. You won't be able to see that if the clouds were there.
So emotional.
Wow.
You like that?
So emotional.
Yeah. That's good music.
If an asteroid hit it, the atmosphere, since it's like water, would it explode when it hit the atmosphere?
Since its atmosphere is 90 times as thick as ours, it burns up asteroids faster than our atmosphere does. So there are a lot less asteroid impacts on Venus. Most of those asteroids burn up as they become meteors, and you have very few impacts. If it were a big enough piece, it would hit Venus, and there are craters on Venus. But the craters, just like we have erosion and weather here, they've got it there too. Venus has it, and it erodes craters too. So a lot of the craters get eroded.
How hot is space around Venus and Mercury?
Space is cold.
It's cold around those
Yeah,
things?
it's cold around it. Of course, the sun would heat it up, but on the side that's night, the space is really cold in the shade.
Mm-hmm.
The space is warm in the sun. If you're an astronaut just floating around Venus and you were in direct sunlight, it would be hot because the sun's right there. It'd be like being near the sun, you know. If the sun's shining right on you, it's going to be hot. But if you get around on the other side of Venus where it's in the shadows,
Mm-hmm.
it's really cold, all the way down to just 20 or 15 Kelvin, which is near to absolute zero. I mean, it's really cold. And the same around Earth. Earth is the same way. In direct sunlight, it's hot, but in the shadow of the Earth, it's cold.
Does it just get colder and colder the further out you get?
Yeah. And then the coldest it'll get is about 3 Kelvin, which is near absolute zero. It stays a little above absolute zero with the radiation that's just out there in space.
So how do those planets stay warm with all that cold space around them? Like,
if they don't have an atmosphere, they don't.
all right.
If they have an atmosphere that traps heat, they can stay warm.
Okay.
Earth has an atmosphere that traps heat. Venus has an atmosphere that traps heat. Both of those planets stay warm. The moon, warm on the side where the sun's shining, cold in the shadows or on the other side.
Okay.
You see what I'm saying?
Yeah.
Because it has no atmosphere. Those are good questions. All right, let's see what it would be like if you went to Venus.
Recently, astronomers have built up a detailed picture of Venus's atmosphere. Imagine a probe hurtling toward the planet. What would it see? 50 miles above the surface, it hits a thick layer of cloud. But this is no ordinary cloud. It's made of vaporized acid, corrosive enough to burn through steel. Scientists believe that the acid clouds are a byproduct of Venus's violent history. Gigantic volcanic eruptions blasted billions of tons of sulfur high into the atmosphere. There, it mixed with water vapor to form concentrated sulfuric acid. As the probe breaks through the upper atmosphere, it slows to make a low pass over the surface. The terrain is dominated by dormant volcanoes that tower 3 miles into the atmosphere. Deep channels, forged 1 million years ago by molten lava, stretch thousands of miles, one longer even than the River Nile. Probe sensors reveal an atmospheric pressure 90 times greater than on Earth, large enough to crush a car. But the biggest problem is temperature. The atmosphere is nearly all carbon dioxide. Just like on Earth, this gas acts like a pane of glass in a greenhouse, letting the light through, but not the heat out. On Earth, increased carbon dioxide levels are causing small rises in temperature. But on Venus, they have pushed the temperature to over 900 degrees Fahrenheit.
Brutal. Whoa. That was a good video, wasn't it? Here's what the surface looks like.
Good stuff, yeah.
Did it say in that in your book if this is a radar picture or a UV picture?
Ultraviolet.
UV, okay. This is a map. Just like you can spread out an Earth map to be flat, this is a map of Venus if it were flat. And they've named these 2 continents. This continent is called Ishtar Terra. Can you say Ishtar Terra?
Ishtar Terra.
And this continent is called Ishtar Aphrodite.
Is Aphrodite Terra.
Oh, Aphrodite Terra, thank you. Ishtar Terra, Aphrodite Terra. And these are like continents on Venus. They're raised areas. They're areas that sit up. And way back 4 billion years ago, when we think Venus had water, oceans, that would have been the only land. There, and then a few islands here and there. Everything in green and blue would have been underwater.
From the island.
And so now, all the water's gone. It's all land. But they still call these continents of Venus. And the continents, the raised areas, take up about 8% of the area of Venus, where on the Earth the continents take up about 30%. So this just gives you some idea how Venus is a little bit different from Earth. A lot of volcanic features on Venus. There's a volcano that sticking out from the ground. Like they said, they can be 3 miles high, these volcanoes. That's not as high as the biggest Earth mountains, though. The biggest Earth mountain is Mount Everest, which sticks up about 5 miles high. So our mountains are actually a little bit bigger than Venus's mountains. But Venus doesn't have plate tectonics like we do. They don't have plates floating around and bashing into each other, forming mountain ranges. What Venus has instead is plates, it's crust that is kind of rigid, and it has hot lava below it that pushes up on the crust and sometimes breaks through. This structure right here, you see this circular structure right here, is called a corona. Like the beer Corona. You know what I'm talking about? You probably don't. Well, you might have seen commercials. I know you haven't drank beer.
No.
But a corona on Venus is a place where the lava has pushed up from underneath and cracked the surface. Imagine it's kind of like there's a big guy underneath pushing on the crust. And he punches it and it pushes it up. And then that lava will fall back down. It pushes up and then it falls back down. So you see the cracks on Venus where this lava is pushed up and then falling back down. All those little lines there are cracks. And sometimes the lava punches up through and spills out onto the surface and forms what's called these little pancake domes. This is where lava is actually squirted out of a hole and then ran on the surface and hardened again. We would call that on Earth, we would call it a shield volcano. There's one there, and there's one there, and there's one there, where some lava comes out and just spreads over the surface. And so this is called a pancake dome. Hello, here we go. Pancake dome, pancake dome, pancake dome, pancake dome. Corona is the big cracked area. Coronas and pancake domes. That's what you find on Venus.
The corona, what's
Here's a close-up of the pancake dome. Doesn't it look like a pancake?
Mm-hmm.
Someone thought it looked like a pancake, so they called it a pancake dome, and it's actually lava that's spilt out. And like I said, the Russians, they landed there. This is a Russian lander. That's a picture from the surface of Venus. That's the lander. It unfolded. The first ones they landed only lasted for a couple minutes, and then later they made the spacecraft hardy enough where it could last for a few hours. And I think the last one that landed there lasted for like 2.5 hours or 3 hours before it burned up. And
what was the corona from?
the corona is from lava that's under the surface of the crust, pushing up on the crust, cracking the crust. And then what it'll do is it'll come up and push up, and then it'll withdraw. And so the cracked area comes back down. But sometimes it breaks through the surface and spills out lava and forms the pancake domes. Make sense?
Yeah.
All right. That's it. Do you want to see a video? Video footage?
This intense music again.
Space School!
The second planet from the sun.
You should watch